Alright, this is just a short little video to get us started with motion constraints. So what I'm going to do first is I'm going to find a piece of structure. That should do. I'm going to ground this. Now since I want to do some sort of rotational motion, I need to have an axle. So go to my motion folder. The first thing you always want to do is put down a bearing flat. I'm going to rotate this on the x-axis to see the bottom of it. And I'm just going to put down a couple of these. Now, what I'm going to do is I'm going to mate the surface of that bearing flat to the surface of that. Apply that. Now when I look at the top, okay, I already know that I want to use a 12 tooth gear and an 84 tooth gear. So that means that my bearings have to be separated by one empty spot right here. You'll want to take some time to actually grab some of these and see how much spacing you need, depending upon which gear you use. All right, now I'm going to do a quick little tangent constraint. Offset it by 0.009. And over here, so that bearing flat's secure. Now for this one, so you need to have, for a bearing flat, you need to have one mate and 3 tangents. So there we go, those are nice and locked in there. Alright, we can then place screws in those bearing flats, but I've already got a video showing you how to do that. Now for some drive shafts. I'm going to use 3-inch drive shafts. They're just called shafts in the folder. I'm just going to place 2 of those. And for these, I'm going to use an insert constraint. So that's the fourth one over. And I'm going to look to see if I can get that arrow. So if I zoom in here, we want to get this little circle here. And get that arrow. And here I want this arrow pointing up. Now we see that it's it's just kind of stuck there. I can change the solution. I'm going to leave it on this first solution, but I'm going to offset it negative 0.375. And what that does is puts a little bit, actually, it might not be enough here. I'm gonna go to this drive shaft, and I'm going to edit this offset. I'm going to change it to negative 4.5. It doesn't look like it's enough. Make a negative 5. That looks better. That gives me a little bit of space. I can put a shaft collar on it. Alright, now let's get this other drive shaft in place. So we'll use the insert constraint. Get this ring. Get that ring. We'll offset it by negative 0.5. Alright, now let's put some shaft collars on these. Okay, here's a shaft collar. I'm going to need 2 of them. And I'm just going to mate this surface to that surface. Apply that. That surface. And then we'll mate the center line. Now we have to get the center line, not of the drive shaft, but the center line of the bearing flat. to zoom in here and get this edge. And looking here, I see that the drive shaft just doesn't come out quite enough. So I'm going to go back to those drive shafts again. And I want to edit that negative 0.5. Just isn't enough. 0.56. That looks better. So negative 0.57 is what we needed. So that means for the second one, we need to do the same thing. All right, now this shaft collar, it's not moving with the drive shaft, so now I need to do an angle constraint. We'll use the middle solution, and we'll get this surface with that surface. Let's rotate this around. It will. There it is. So angle constraint, center solution. There, and we'll choose that surface. And now, if we move this drive shaft, this shaft collar will move with it. Like that. Okay, now let's put some gears on this. I'm going to pull up an 84 tooth gear. And a 12 tooth gear. Okay, so for this one, I'm going to use an insert constraint. I'm going to get this, make sure you get this outside edge here. Again, I want to get this circle on the bearing flat. But notice that if I go to turn this, it's not turning the drive shaft. So I got to use an angle constraint to tie those together. Before I do that, I'm going to move this slightly out of the way. That way I can see the inside of this gear. So now when I do my angle constraint, it doesn't want to do it. You know, I'm running out of memory on my computer, but those two are locked together. Now I need to do another angle constraint, or I'm sorry, another insert constraint for the 12 tooth gear. But we see that there's a problem. They don't line up. That's because this 84 tooth gear has this collar on it where this 12 tooth gear doesn't. So I'm going to undo that. I'm going to put a spacer there. Now the spacer you need is found in the structure folder, and it is a 4.6 millimeter spacer. I'll rotate this on the x-axis. And then I need to do an insert constraint. I'm going to get this back edge with that there. And now I can do an insert constraint with that 12 tooth gear, and that lines them up nicely. Okay, I'm not going to worry so much about getting the teeth meshed together, not yet. However, I do need to do another angle constraint to get that 12 tooth gear. There we go. I'm just going to rotate this gear around a little bit, get it close. Right now I can do a motion constraint between these two gears. Now for this one, you always want to choose the reverse because, when one gear is turning clockwise, the other one turns counterclockwise. And what I'm going to do is I'm going to do 12 divided by 84, which means that I need to click on my 12-tooth gear first and my 84-tooth gear second. And now, there we go. We can see that they're turning properly there. All right, after that, it's a matter of applying wheels and putting screws and everything else.